somewhere in the deep sky, there's an object that looks like a star. It's roughly the size of our entire solar system. It glows an almost impossibly deep red. And it is producing more energy than any star in the known universe could physically generate. Not twice as much, not 100 times as much, about 100 billion times more. So what exactly are we looking at? And why are astronomers saying out loud that this object simply shouldn't exist? Since the James Webb Space Telescope began peering into the deepest, oldest corners of the universe, it kept running into the same strange puzzle. Tiny, unbelievably bright red dots scattered across the early cosmos. Too compact to be galaxies, too luminous to be ordinary stars, and too faint in certain wavelengths to be the black holes astronomers already knew how to identify. Scientists started calling them, quite literally, little red dots. Dozens of them, showing up again and again in JWST's deep field images, and nobody could fully explain what they actually were. Then, in August 2026, one of these little red dots turned out to be extreme enough that it finally gave researchers a real answer. It's called MOM-BH*1, named after the survey that found it, nicknamed Mirage or Miracle. This object dates back to roughly 660 million years after the Big Bang. That's early enough in cosmic history that the universe itself was still, in a sense, figuring itself out. At first glance, through Webb's instruments, it looks almost exactly like a single, enormous star. Compact, roughly the size of our solar system, producing a spectrum of light that, on the surface, resembles a stellar photosphere, the glowing surface layer you'd expect to see on any ordinary star. But when the lead researcher, Rohan Naidu at MIT, ran the numbers on how much energy this thing was actually putting out, the math simply didn't work. You can't be powering this by nuclear fusion, Naidu explained, which is the energy source that sits at the heart of all the stars. No fusion reaction, anywhere in known physics, can produce 100 billion times more energy than a star. So if it isn't a star, what is it? The leading explanation is almost stranger than the mystery itself. Researchers believe MOM-BH*1 isn't a star at all. It's a black hole, actively feeding, buried inside an extraordinarily dense cocoon of gas. Here's the part that makes this genuinely new. Black holes on their own don't usually look like stars. They're either invisible or surrounded by a violent, chaotic disk of matter that spikes unpredictably in brightness. But wrap that feeding black hole in a thick enough shell of gas, and something different happens. The gas absorbs and re-emits the black hole's radiation so many times that, by the time light escapes to reach our telescopes, it mimics the smooth, steady glow of a stellar surface. In other words, the red dot and the black hole are the same object, just seen two different ways. A black hole wearing the disguise of a star. There's a second piece of evidence that makes this discovery even more significant. When astronomers analyzed the object's spectrum in detail, they found something called a Balmer break, a specific dip in the light spectrum with a strength of 7.7. That's sharper than anything ever seen in a normal population of stars. Combined with signs of thick, fast-moving gas winds around it, this gave researchers the first direct evidence of something called Super-Eddington accretion. Normally, a black hole can only feed so fast. As it pulls in gas, that gas heats up and radiates light, and that radiation pressure eventually pushes back, capping how quickly the black hole can grow. Astronomers call this ceiling the Eddington limit. But wrap the black hole in a thick enough gas cocoon, and that radiation gets trapped instead of escaping outward. The pressure that normally slows feeding down simply can't build up fast enough to stop it. The black hole eats faster than physics is supposed to allow. Think of it like drinking through a straw that's too narrow. Normally, you can only drink so fast before your own throat pushes back. The Eddington limit works the same way. Radiation pressure is the body's natural too fast, slow down signal. A thick gas cocoon is like swallowing that signal whole. The black hole never gets the warning to stop, and this single object might finally explain a mystery that's frustrated astronomers since Webb first launched. Every little red dot is consistent with being a black hole star embedded in a generic early galaxy, Naidu says. If that's true, then all those dozens of unexplained red dots scattered through JWST's deep field images may all be the same phenomenon. Black holes disguised as stars, growing far faster than anyone thought possible, all across the early universe. That matters enormously, because it touches one of the biggest unsolved problems in astrophysics: how supermassive black holes, some weighing billions of times the mass of our Sun, managed to grow so large within the first billion years of cosmic history. Standard growth models simply run out of time. Super-Eddington feeding, hidden inside gas cocoons, might be the missing piece. But there's a complication too. The same gas cocoon that lets the black hole feed faster can also fake the exact spectral signatures astronomers normally use to weigh a black hole's mass. A separate study, published earlier this year, found that this effect, called resonance scattering, could mean some previous mass estimates for little red dots were overestimated by a factor of up to 100. So this discovery doesn't just answer a question, it reopens several others. As Naidu himself put it, our picture of this object is evolving very rapidly, which is, in a strange way, the most exciting part of this story. We're not looking at a settled answer. We're watching astronomers figure it out in real time, a few 100 million years of cosmic light arriving at exactly the right moment for us to catch it. If this changed the way you think about what a star even means, let me know in the comments. And in the next episode, we're staying in this same era of the early universe, for a galaxy that isn't hiding one black hole, but 3, all inside a single system. Subscribe, and I'll see you there.